The recent geomagnetic storm, which created beautiful auroras at latitudes below 40 degrees, was the strongest such event in the smartphone era. Earlier this week, it was a delight for night sky enthusiasts in countries located at mid-latitudes. The sun's intense activity peaked last week, leading to the formation of stunning auroras in regions where such phenomena are rarely observed in their night skies. Social media was flooded with images of the northern lights, and many people likely wondered how auroras occur and how common they are. According to the Space Weather Prediction Center at the National Oceanic and Atmospheric Administration, NOAA, the recent severe geomagnetic storm was classified as G5 and is considered the strongest event of its kind since 2003. At that time, the storm was so severe that it caused generator failures in Sweden and South Africa. On average, first storms of this magnitude occur during each solar cycle. A solar cycle lasts about 11 years. Solar activity during each cycle fluctuates from a peak known as solar maximum to a trough called solar minimum. We are currently approaching or possibly experiencing the maximum of cycle 25. As you may have noticed, 2003 was more than 11 years ago. However, solar cycle 24 was somewhat unusual and particularly weak, resulting in no G4 or G5 storms, whereas around 100 G4 storms are expected in each cycle. As solar activity increases, sunspots, which are slightly cooler than their surrounding areas, become visible. These spots have extremely strong magnetic fields, and the behavior of these fields leads to significant events in space weather. The source of this week's auroral activity is a sunspot named Air 3664, which is 16 times larger than Earth. According to Dr. John Morgan, a space weather scientist, magnetic field lines have a fundamental property: they generally cannot pass through one another. This characteristic means that by intertwining, they store energy like a twisted spring. Then, when a process called magnetic reconnection occurs, these fields rapidly weaken and can release explosive energy into space. The magnetic emissions from sunspots can create solar flares. The radiation from these flares is so intense that it ionizes atoms in Earth's upper atmosphere upon arrival 8 minutes later, causing it to puff up. Such events lead to radio blackouts, errors in GPS satellite operations, and satellites being dragged into the atmosphere. The AR 3664 sunspot produced an X5.8 flare, which is the second strongest flare in the current cycle. However, it is not just solar flares that affect Earth. Coronal mass ejections, CMEs, are also significant phenomena in space weather. CMEs are massive expulsions of plasma from the sun's corona and can launch billions of tons of coronal material into space. Charged particles from the sun constantly collide with our planet. However, CMEs arrive with much greater energy. These particles travel at thousands of kilometers per second and follow magnetic field lines when they reach Earth, typically colliding with the atmosphere around polar regions. Places like mainland Australia, Tuscany in Italy, and Southern California are nowhere near the poles, yet auroras were visible there. Auroras even appeared in areas with high light pollution. The reason for this is that the volume of plasma ejected from the sun was exceptionally large this time. Additionally, Earth was in the right place at the right time to experience multiple CMEs simultaneously. In fact, 3 such events combined because the last CME ejected from the sun had a high speed and was able to catch up with the previous 2. Some of that plasma reached Earth and impacted the atmosphere at lower latitudes than usual. As a result, auroras were observed in many places where they were not expected. The next question is whether auroras can be seen again in non-polar regions. No one can definitively answer that question. It is quite possible that we have seen the peak of auroral activity in the current solar cycle. However, experience tells us that significant events can occur even after the peak of a solar cycle. As a result, those who miss the opportunity to observe the auroras in unexpected areas may have another chance to witness similar events in the coming years. Do you think we are lucky enough to see such beautiful sights in the skies away from the poles again in the near future? Share your thoughts.